In this lecture today we are going to learn about oxidation reduction reaction. So here we will try to understand what do we understand by oxidation and what do we understand by reduction in the upcoming slides. So let's get started. So in order to understand that, first we will have a look into electron transfer reactions. So if you have done types of chemical reactions, there are a few different types of chemical reactions and electron transfer reaction is one of them. Okay, where the electrons are transferred, and that is how the reaction proceeds. So if you have a look over here, there is a nice shiny copper wire which is placed in this beaker that is containing AgNO3 solution, that is silver nitrate. Okay, so let's say some time is spent, it has been there for a while, let's say 15 minutes, 20 minutes. So what will happen? You will start seeing this thing. Okay, over the time what will happen, the copper atoms in the wire, they will be displaced into the solution, and the silver atom from the solution will be depositing here on the wire. Okay, so what's going on here, the solution turns blue because copper 2 ions are released and they're blue in color. That's why you see this nice beautiful blue color. So essentially this reaction is happening. We will study in details what is this reaction about. So copper, first of all, it was in the solid form. It went into the AgNO3 solution, and then what happened, the silver got deposited, and then we had copper nitrate in the solution form, in the aqueous form. Okay, so now let's try to break down this equation in the ionic form. Okay, because we know that when anything is in the aqueous state, for example AgNO3, it can be dissociated. So copper nitrate produced is completely dissociated into ions in the solution like this. We will see that. So let's go ahead and have a look on that thing. So here's our equation in the ionic form. So this is called ionic equation. So solid, it will stay as it is. You can't break down into ions. For here, AgNO3, it will dissociate in the solution, so you can write Ag plus and then NO3 minus. So again your solid will remain intact, and then copper nitrate, it will be dissociated, so you can write like this, right? And then similarly for NO3. So this form of equation, what do we call them as? Total ionic equation. It contains all the ions that are present in the solution, the total information. Okay, and then it is in the ionic form. So it's a good idea to call it total ionic equation. So now if you notice one thing over here, that is if you pay attention on the NO3 ions, what happens? They went in as 2NO3 minus and they're coming out as same. No changes happening over here. However, if you observe copper, it is becoming copper 2 plus, right? Before it was like this, after it is like this. Now this is Ag plus. Now before it was like this, now it is Ag solid. So they are undergoing some change. But if you look at this is not undergoing any change. It came out as it is. So these are called spectator ions. So they are just watching there. They're not participating. They are just there. Okay. So they don't actually they are not contributing to the reaction, so you can cancel them because they have same quantity on both sides. So when you get rid of them, you get this nice equation. We call it as net ionic equation. Okay, so when you get rid of any spectator ions, so you're left with copper solid and 2 Ag ions, and then you're left with 2 Ag solid and copper 2 plus ions. So you cancel these. So this form of equation is referred to as net ionic equation. Okay. Now let's move ahead. Since we have a good idea about what is net ionic equation, what is total ionic equation, on the exam you might be given some reaction, and then the teacher might ask you, can you write the total ionic equation, or can you write the net ionic equation? Then you should be able to do so, and then we will practice a few questions about it. In this slide, we are concentrating on the atoms those are left. So we are left here with copper solid. Let's see, it came in as copper solid. It came out as CO2 plus. So what happened during this process? So it lost 2 electrons, right? How copper can become copper 2 plus? By losing 2 electrons, right? So loss of electrons in chemistry is referred to as oxidation. Okay, so the loss of electrons is called oxidation. So we can say that copper is undergoing oxidation. Now let's focus on Ag plus. So if you focus here, it was Ag plus, now it became Ag. What is happening here? When you go from the plus state towards the neutral atomic state, that means you might have gained electron. So the gain of electron is happening in this part. In chemistry, we say that it is the process of reduction. Okay, so if you're gonna read here, gain of electrons is called reduction. Okay, so that means oxidation is also happening and reduction is also happening. So what do we call this type of reaction? We call it as oxidation reduction reaction, because both are happening over here. Okay, so we say oxidation reduction reaction. This reaction is redox reaction in short. So Red for reduction and then ox for oxidation. So redox, every time we can't write this big name, so we choose a simple name, redox reaction. Okay, so I hope that makes sense. Now moving on, we have these little definitions for a quick review. What we just did, the process in which one or more electrons are lost by chemical entity, we call that as oxidation. Similarly, the process in which one or more electrons are gained, we call that as reduction. And then again, which is oxidation reduction reaction, the reaction in which one or more electrons are transferred, right? So one is losing electron and the other one is gaining electron. Okay, so that is your redox reaction. Now let's move ahead. As we know about oxidation reduction, now we understand about that. Let's try to concentrate on half reaction equation. So what do we understand by that? A half reaction equation is a chemical equation, is a chemical reaction equation that represent one of the redox reaction part. So what do we mean by that? So the half reaction will either just show you reduction, or it will just show you oxidation. So for example, if you pay attention on this reaction equation, copper solid turning to copper 2 plus 2 electrons. So what is happening during this journey? It is losing 2 electrons. This is what is happening, loss of 2 electrons. So what is this? This is called oxidation half reaction. Okay, what do we call it as? Oxidation half reaction, or half reaction for oxidation, right? Now similarly, it can be for reduction also. We can give you a reduction reaction only. Okay, then you will call that it is reduction half reaction. So for example, in this slide, what is happening to Ag during this journey? It is gaining electron and becoming Ag0. So this reaction is called reduction half reaction. What do we call it as? Reduction half reaction. Okay, I hope that makes sense. Now they're saying if we compare the number of electrons in the two half reactions, okay, they're not the same, right? So in copper, from going from solid, and then it was losing 2 electrons. Okay, so there is a loss of 2 electrons, but if you pay attention on this one, which is Ag, so Ag is +1, so it needs to have 1 electron to become Ag. So here it is gaining 1 electron, here it is gaining losing 2 electron, right? So the number of electrons lost in a redox reaction. So I'm talking about redox reaction now. Okay, when you want to combine them, when you want to add oxidation half reaction and reduction half reaction, you are adding them, this plus this, to form a full redox reaction. Okay, which is this one. So what will happen over here? You can't add unequal electrons, so you have to make them same. So how this can be turned to 2? You multiply this full equation by 2. So what would be the result? I'm going to write that when you multiply by 2, it will be 2Ag plus 2 electrons becomes 2Ag, right? Now you can go ahead and add them. Okay, so this is one of the rule. So when you will add them, you will have copper plus 2 Ag ions, which is over here, and then on that right hand side of the arrow, you have copper 2 plus and then 2 Ag solid, right? So this is your redox reaction which you got by adding the two half reactions. So this is oxidation half reaction, and this is reduction half reaction. Okay, so very simple, very easy. So let's move ahead. So let's do one practice problem together, and then we'll move ahead. So writing half reaction equation. Okay, so here you have to practice writing half reaction equations. Aluminium solid plus 3Ag plus, and then it is turned into aluminium 3 plus and then 3Ag solid. Write the oxidation and reduction half reaction. So you have to write OHR, oxidation half reaction, reduction half reaction, okay, for this reaction. Okay, so let's dig into that. So first we have to identify who out of aluminium and silver, who is undergoing oxidation and who is undergoing a reduction. So let's first try to concentrate on aluminium's journey. So aluminium, it started as a neutral atom, but it is ending as a aluminium 3 plus, right? So what we can say is how it can be possible by losing 3 electrons. So here loss of electrons, essentially 3 electrons. So that means what is my oxidation half reaction? It is Al turning into Al3 plus 3 electron. This is my oxidation half reaction, right? And if I concentrate on this thing, which is my next chemical entity, which is silver, right? So Ag plus becoming Ag solid. So this is Ag plus. How it can become Ag? By gaining electron, and it is gaining how many electrons? So 1 Ag will be gaining 1 electron, but then I have how many? 3. So it will be gaining 3 electrons, right? So let's write the reduction half reaction now. So reduction half reaction will be, so it would be 3A